We're ready for the very first talk of the day. This is Joseph Zammit.
Yep.
Also, not the very first talk at
No.
uh,
Yeah.
Django Day Copenhagen, but someone who has been very consistent in delivering fantastic talks. So we're very glad that you're back.
Thanks.
And very, very exciting topic that you have for us. Let's give a big hand for Joseph.
Good morning, everyone. I'm happy to be here with you for another Django Day Copenhagen event. And this time, I'll talk to you about marrying Django and FastAPI. So, quick show of hands. Who here has heard about FastAPI? All right. For those that didn't raise their hands, it's the fastest growing web framework. This is the JetBrains developer survey numbers. So in 2021, it was 14%. In 2023, it's 25. Probably by now, it's doubled the number from 2021. There is this nice little website called Star History, which shows the graphs with GitHub repo stars. And this shows that FastAPI is very well liked alongside Django and Flask by its users, but it's probably going to surpass both of them. So my question to you is now, instead of just hearing who has actually worked with it. All right, and let's see, what do you like about it? Why did you work on it? Did you work with it instead of Django or Flask, for example? Lightweight, didn't need a CMS. More reasons? Type hints, yes. More reasons? Simplicity, yes, that everyone has his own opinion on it. In my experience, I worked on it for a client, so I didn't really choose. And the reason was async or native async by async.io. So I would like to clarify why async is important in our Python web applications. So here there's this simple script snippet that loops from 1 to 3 and passes them to the say hello function. Time.sleep here suspends execution for the amount of seconds that we want and then prints the time. So if we start at the 0-second mark, it takes 1 second to print the first, another 2 seconds to print the third one, and another 3 seconds to print the third one. So total execution 6 seconds. Here in the comment, time.sleep is simulating an I/O blocking call. Why I/O blocking? Because a process can be limited, the speed at which it progresses, it can be limited by CPU, by memory, by access to cache. And when it's I/O bound, we mean that the rate at which the process progresses is limited by input-output. So for example, if you're reading data from a file, you're limited by the file system. If you're making an API request over the network, you're limited by the network. So that's what we mean by I/O blocking. So let's look at async now. Sorry, this is the execution of the sync process over time. So this is the first one to print the first one, 2 seconds, 1 second, 2 seconds here, and 3 seconds to print the third one. So let's look at an async snippet. This uses async.io library, which gives us the async await syntax. And here we use the Python 3.12 task group to run the tasks passing 1, 2, and 3. So let's look at the output of the async.io snippet. As you can see here, instead of taking a total of 3 seconds, they appear like they are started all at the 0-second mark. In fact, this is when they are printed. So, but they are not running concurrently. If we compare them, it's an async is the same thread doing all the work, but in contrast to synchronous, in async, an I/O blocking operation does not block the progress from doing the work. So that's why they appear like they have started off from the 0-second mark, because these are not blocked. The subsequent tasks after the first one are not blocked by the first I/O blocking task. Um, so when should we use async I/O? When is it important? When does it make a difference? And the answer is when I/O is the bottleneck. We'll soon get back to this. I hope that is clarified. And we'll soon get back to I/O bottlenecks. For the past year and a half, I've been working for a company called DeepDesk. It's about enhancing the lives of customer support agents by providing a bunch of features as I pasted in this LinkedIn post here. And to do that, there's a whole architecture. We deploy the system in a multi-tenant architecture, so every client has their own set of services and architecture kind of. So for the purposes of this talk, I simplified that architecture into a few microservices here. So these, let's start from the front end, and UI components are here. They talk to two services. One of them is the account config, which we call admin, because the admin interface by Django is one major feature of that, and the project features backend, to which the front end and the user interface components talk to actually use the product. Then each of these talks to a bunch of microservices. These services, we can treat them as a black box for the purposes of this talk, and they are mostly deployed in Flask and FastAPI. This product features backend was deployed in Flask, and the account config for the Django admin was deployed in Django and DRF synchronous. So we have one process here, and they also shared libraries, each with their own repo, admin and backend. So from now on, I'll refer to them as admin and backend to simplify the talk. So we had this requirement where customers wanted to upload files to their configuration, to their account configuration, and hundreds of files. So, of course, we wanted to take advantage of async or remove the bottleneck of input-output. And to that, to move from this here to something that can handle async, was the shortest path was to use Django async. And we did. We started using async. This was around last December, so it was kind of just coming out. And it's one thing to start an agreement project using Django async, but we had a large code base. We had our own middleware, custom middleware. We used third-party libraries, and the experience to migrate those was not straightforward, even because I wasn't personally experienced writing Python async code. But it was a bit hard, and also we couldn't work with DRF in an async manner, so those views were still kind of lost, because DRF is not async and is not planned to work async anyway. My personal experience, I felt a bit like this, sprinkling async await syntax and also the sync to async and async to sync adapter functions around the existing middleware, and also rewriting tests for those. So that felt a bit time consuming and kind of wasn't that promising going forward. Now, I should acknowledge that the effort to make Django, which is a huge framework, work async is a huge, it's a huge effort, and it shouldn't go unappreciated. But this is my personal experience, and maybe it's biased from the fact that I've been writing synchronous Python and Django applications for around 15 years. So maybe that was one of the reasons. So with that said, so now we have this structure. At the same time that this was happening and we saw the effort in rewriting those, there are people experienced with FastAPI on the team. And so the argument was there were other issues that related more to reworking these two microservices into one, because this features backend made requests over this account to the admin, and we weren't reaping the benefits of separation of concerns. So while these two can in theory scale together. We weren't, can in theory scale separately. We weren't scaling them separately. We expected the demand on the service to be, on the backend, to be much higher than the admin, but it wasn't a big deal. So the decision was made to join these two into one. And initially the idea was to have FastAPI and remove Django completely. But at the same time this was happening, I noticed a talk at PyCon US. And it was about using the Django ORM from a FastAPI application. The talk was by Mia Bajic. There's a link to her profile and to her talk because she later then delivered it also at DjangoCon Europe. The same talk about using the Django ORM from FastAPI. And to us, at least to me, I'm referred to as the Django guy, by the way, at work, because I'm always seeking the good parts of Django. And it wasn't just the good parts, it was that we had to rework a lot. We had all the data models defined in Django. We were making heavy use of the admin. We had a lot of code in DRF with some business logic in there. So it wasn't just that straightforward. It would be a big effort anyway to migrate to FastAPI completely. So I proposed we look at this and proposed a suggestion where we join these two services and we remove Django async process, and we have two processes on one host. One is FastAPI exposing the backend, and the other will still be sync Django and Django REST framework. They will have the same database. The shared libraries that we maintain and have to be maintained to work for both servers can be reworked into this now monolithic service. And also we reap the benefits of keeping the Django models defined in Django. What are these benefits? Off the top of my head, migrations. How do you track the evolution? It's an excellent tool to track the evolution of your database models. The Django admin, you simply define a model and you have a basic CRUD that you can very easily extend and customize. When writing tests, you have mature factory libraries like Factory Boy and Model Bakery. So those are not to be underrated when doing this kind of decision. So we had this. So we worked towards this. This also was the path of least resistance, because we just created alongside the other Django apps, we just created a backend folder and put a main.py to host the FastAPI instance in it. So this is it. This is our wedding ceremony for the marriage. That's all it takes. So, or all it took for this code. By the way, there's a prototype, a proof of concept repository. It's linked in the talk, so it's on GitHub and you can check it out, run tests, run it, whatever. So this is it. So we have the FastAPI instance to which you attach routes. You attach configuration here. We're attaching a middleware that this is the only place where we use sync to async adapter function. And there's a DB connect function. It's synchronous and it connects the default database. Now this is Django internals. I'm not sure this is the best way to do it, but it works. We await it since it's converted to async, and then we let FastAPI process the rest of the request. So, so that's our marriage. So is that it? Can they live happily ever after now? Let's ask. So with that said, this is, as an experienced Django developer, this is a post by Benjamin here. And I think he's been dealing with working with FastAPI after probably a decade and a half of Django. And I'll give you a few seconds to read it. I relate a lot to the things he expressed in this post. It's actually one of the reasons for this talk. So I assume you read it by now. As I said, I relate to a lot in there. Maybe I have come around on the typing part, because typing I feel video is celebrating. I have come around on the typing because I think by having type annotations, an entire class of errors, an entire category of errors is moved from runtime to type checking time. Also, I feel it makes the code more readable once I got used to it, and also makes refactoring easier, and also results in improved editor support like autocomplete. So the rest I fully relate to. So let's see how we married FastAPI and Django. As one of the points, I asked ChatGPT what makes a good marriage. And among the reasons, ChatGPT said number 4 is the factors maybe for a good marriage are compromise and flexibility. So let's see the compromises we made in our structure. So initially when we started with the main.py, we could expose a FastAPI root or view in Django, and it has to talk to the Django ORM. To talk to the ORM, you just import it and run statements, ideally using the async ORM features Django provides. So how do we go about implementing this box here? And for that, we used concepts from the domain-driven design. So domain-driven design has been around since 2003. There's a book by Eric Evans. There's a link there's not a link, there's the name of the book in the talk notes. And domain-driven design is about prioritizing the rich. Anyway, you can read the description. I think everyone here who is familiar with domain-driven design. Okay. So it's an alternative way to structure your applications. It's an architecture approach. It gives you patterns to structure your code. Why? And this definition is taken from a work-in-progress book that is being written by Dawn Wages, who has been a long time. She's been active for a long time in the Django and Python communities. She's writing this book called Domain-Driven Django. And why? One of the reasons. Also, there's a good talk by David Seddon at PyCon UK 2023, which is about domain-driven Python, domain-driven design and Python. I think Django and DRF give us, they break the complexity of a web application by giving us, by breaking it down into smaller, more manageable components, giving us engineers a language to talk about what we are going to do. For example, if we get a ticket, we talk about how we're going to do it in terms of models, middleware, views, serializers in the case of Django REST framework. Domain-driven design is about abstracting further away from what the framework provides. And since we're marrying two frameworks, I think this is ideal. So this is from the proof of concept repository. And here we have a project, which is a Django project. Here we have the agents up. So far, it's just Django. The admin, the models.py, and we have a conversation model, which has one or many messages. Now, the objective is to expose an async route to handle a webhook that updates the data in here, conversation messages, and makes an IO-bound request to external microservice. So for that, we will use a FastAPI route. So we have the structure, the root and the ORM. These are already in place. That's what we get when we started. How do we structure this? And we used domain-driven design concepts. So we have repositories here, which a repository in domain-driven design abstracts the persistence layer away from the data access. Services encapsulate business logic. So if we have a handle webhook business process, we will have a service for that. And Pydantic models are different from the models as we have them in Django. Because in Django we have data models. In models, I have written Pydantic. They don't need to be Pydantic by DDD, by domain-driven design. But Pydantic is the de facto, I think, data validation library in Python now. And so we define our models using Pydantic. And they reflect business models or business. And one of the objectives of domain-driven design is ubiquitous language, which means we use the same terms and vocabulary as used in, for example, tickets as written by product owner, or even the user interface. So we use this structure. Repositories here return models which are not Django model instances, but instead the Pythonic models we have here. And one constraint or one compromise that this embodies is that we talk to the Django ORM only from the repository. So this is how the structure looks like. So this is the Django project, and we created a backend directory which hosts the FastAPI. Then we have a list of domains. In the case of the proof of concept repository, the domain is called messages because we are dealing with messages. And then it has models, repositories, services, and routes. And dependencies is something that we use for plugging things together. The advantages here are the flexibility this gives us. So the flexibility. If I need to split these models, I just create a subdirectory and add more models there. If this needs to be merged into some other domain, we just merge it. There are no framework artifacts, no framework components. It's all our code. So we have total freedom there. If we want to split it, again, it's easy. So it's very, very maintainable over time. Other advantage that I experience using this structure and that domain-driven design advertises is the bounded scope when you look at code. So the monolith is much bigger than this. It's not just one app and one domain. It's a lot of things. But when you're solving, this is a key advantage, when you're solving delivering a feature from a user point of view or even a product point of view, you just need to look at one domain. So I just look at these files and I have everything in there. And I go ahead and understand that and work in that direction. So I think the flexibility gained by the compromises we made is really nice. So yeah, so I spoke about compromises. Let's see what compromises we made. Again, I mentioned that at repository level, it's the only place we talk to the Django ORM. The ORM in Django provides async functions, which makes our code very readable because we don't need to use any adapters in our code. Here, we do this conversion. So we have these converter functions. In DDD, I think the name of the pattern is factory. You could have classes that do this, but we just use a function here that converts from the ORM conversation, which is the Django model instance, to the object, to the class we use in the domain models, to a domain model. And that way, the ORM is dealt with only at repository level. This means that we can write synchronous tests, even though the async functions, even though the repository exposes async functions. So you do that using async.io.run. And the point here is that we hit a wall, as in Benjamin's post earlier, when we try to use factories asynchronously. So we limited tests at repository level to be synchronous. These are the models that I mentioned earlier, the domain models. They are implemented using Pythonic validation library. And the rest of the application is a normal FastAPI application. So someone who comes from FastAPI at root level, at service level, they would see the usual async code with dependency injection features that FastAPI gives us. And these are the tests. They are async as well at root level. So we use fixtures, which are we override dependencies using FastAPI tooling. And so the way we write tests is synchronous for repositories going to the ORM, and async for the rest of the FastAPI application. So this exercise taught me that it's not about technology, and I hope I demonstrated to you that choosing between FastAPI and Django is a false choice. They provide more opportunities than threats to each other. I was born and raised on an island in the Mediterranean, and this is my favorite beach. My parents used to take me there when I was a child, and my friends hate it because it doesn't have sand, so it doesn't meet the definition of beach for some of them, and it's also a hassle to get to, so it's not as accessible. But to me, the fact that it's not as accessible is an advantage because I like it's rarely crowded, and also I'm not a sand kind of. I don't like sandy beaches that much. So I even know when to go there or not, depending on the wind. So whenever I think about going to the beach, I don't even make the decision of which beach to go to. I just go here. And I think we do it a lot about the set of tools we're experienced with. So it's not about tech. It's about the familiarity and experience of the team with the technology. We used FastAPI in contrast to, for example, Django Ninja, which occupies a similar role in the whole ecosystem because we had team members who were experienced with FastAPI. I was experienced with Django, where they invested a lot in Django, where they invested in FastAPI. So marrying together, making some compromises, resulted in the flexibility to have something maintainable to work onwards. That's it. Thank you.
Oh, thank you. So we have a good deal of time for questions, and I'm gonna ask a question straight away. So with FastAPI and also async Django, we see more async entering. It's becoming more accessible. And I guess you can ask the question: is it does that mean that that it's easier to do some of the things that we used to do with task queues?
Yeah.
Or is it on the other hand, should we keep using task queues and try to avoid some of the async? How would you see that?
Thank you, Benjamin. Very, very good question. So, as I mentioned earlier, I explained why to use async, and the conclusion was that async is great for when I/O input/output is the bottleneck. So async works in the same process, but if the bottleneck is CPU, you don't gain much. Async doesn't give you a lot. However, if you want to, that's where task queues come in, because with task queues you can distribute computation over more than one process or over more than one host if you want to. So that's with async you cannot do that. Async gives you the benefits. You reap the benefit of async when the bottleneck is I/O. Does that clarify?
Yeah, it certainly does.
Thanks.
Do we have a microphone for the audience? Yes. Audience, do you have any questions? One in the back. Do we have a microphone for the audience?
Thank you. I imagine another way you could have done it would be to reproduce the ORM in like SQL Alchemy or whatever FastAPI would usually use.
Yeah.
And I guess one reason not to do that would have been that you have to rewrite things twice and keep them in sync. But is that the reason you didn't do it that way? Or like, is there some tool that'll automatically convert my Django models to FastAPI?
We didn't look into that because this, as I said, it was the path of least resistance. We kind of tried it, saw that it works, and continued building with because we didn't need to. We kind of solved it that way. And SQL Alchemy, probably there is some tool to migrate, but yeah, as you mentioned, there would probably need some downtime. Like this, we had zero downtime because nothing is changing. We are just migrating APIs from one service to another. So from a user point of view, nothing has changed. It's just the underlying architecture. SQL Alchemy, it's a different tool, I guess, compared to ORM. We could compare them, but we didn't get to that point. We try to use the path of least resistance. Thanks for the question.
we have time for more questions. Yeah, and I was the one who had this post on social media. I'm okay now, but another question from me then, Joseph, noticing that there is a lot of work with pydantic models, and Django Ninja offers a kind of translation layer between the Django models and the pydantic models. Did you enter that territory, or
We
are you
didn't.
happily building those two worlds separately?
We are not building them separately. They are part of the same repository now. So, but we didn't get to this. We didn't invest any time into Django Ninja because we were invested in Django and FastAPI, and so we just used those. We didn't. So the option was either to go with one or the other. So yeah, we had a lot of experience with FastAPI and the team, so we just went that way.
Yeah. Does the internet have any questions? Don't be shy, internet. Otherwise, thank you so much for presenting a very exciting topic. Thank you for also all your work on the prototype. I suggest we all go and try it out and gain some more experience with this exciting new territory. Thank you, Joseph.
Thank you.